is your Unit 8 review video. So here we have our two parametric equations. We want rate of change, means derivative, y with respect to x, when t equals 4. So we're going to do derivative of y over derivative of x and then plug in 4. We are going to have to simplify the whole way down because this is going to be a multiple choice question on the test and they're not going to leave it unsimplified. So derivative of square root is 1 over 2 square root of whatever stuff that is. So 2t squared plus 4. And then you chain on, which I'm just going to erase the numerator so I don't have to, put a dot and write it off to the side. Chain on the derivative of what's inside, which is going to be 4t. And then actually the 4 divided by 2 will reduce. 4 divided by 2 gives us 2. I'm going to do that just to keep the numbers a little smaller. And I just bumped the projector so it froze. Hold on a second. All right, so I had 4 over 2. I just reduced it to 2 and just erased it. All right, so that's derivative of y. Now we're going to do derivative of x. That will be 3t squared minus 2t. And we are going to do such that t equals 4. Did this freeze again? Hold on a second. Okay, hopefully we're good now. We're going to plug in 4. So that's going to be 8 over, 16 times 2 is 32, plus 4 is 36, square root of 36 is 6. And then down here, that'll be 16 times 3 is 48, minus 8 would be 40. So let's see, this is going to be 4/3 over 40. Sometimes I like to put that over 1 and then just multiply by the reciprocal. The 4 and the 40 will reduce to 1/10. And so we end up with 1/30. So you do have to fight all the way until the very bitter end there. They're not going to leave it unsimplified for a multiple choice question. But you do have choices. And so again, usually if you get about halfway through the problem, you can start narrowing things down at the very least. All right, a curve is defined by these parametric equations. We just want to get the derivative, but we have to simplify it. So same thing we did above, except we don't have to then plug a number in. So derivative of y, derivative of cosine is negative sine, and then there's a chain rule with the 3. So it's going to be negative 3 sine of 3t over derivative of x will be, froze again. So derivative of e to the 9t, it's going to be e to the 9t, and then you have to chain on the derivative of 9t, which is 9. The only thing that is going to simplify there is the negative 3/9 will reduce to negative 1/3. And again, if you get close enough to the answer, then, I have to write the rest of it though, then you'll be able to pick the right one. All right, for this one, we have graphs. Position of a particle is given by x of t and y of t. So this is not y in terms of x. This is in, well, it's not written on there. On the test it is. It'll actually say t there. So there is a t axis on these. This is x of t. This is y of t. What is the slope of the line tangent to the path of the particle? And I was being kind of silly here. I wrote it at times 17,000. The reason I did that is because the time simply doesn't matter. So whatever time, because these are linear. So whatever time they give you, it doesn't make a difference. You're going to do this slope over this slope. It's derivative of y, derivative means slope, over derivative of x. So I'm going to just find 2 pretty points, see what my slope is. This is up 3 over 1, so that's 3. And then this one is, what is that, down 1 over 4, so negative 1/4, and that will be negative 12. All right, given our parametric equations, we want the equation of the tangent line when t equals 2. So we need a point and we need a slope. We're going to take 2 and plug it in. So 2 cubed is 8, double that is 16, minus 40 is going to be, what, negative 24. All right, and then plugging 2 in for y. 2 to the 4th is 16. Let me make myself a little note. 2 squared is 4 times 5 is 20. So that's going to be negative 4. I'm just going to erase that in case I need to put something else there. All right, slope comes from derivatives. So we're going to do derivative of y over derivative of x. So that will be 4t cubed minus 10t over, all right, this would be 6t squared minus 20. And we're going to plug 2 into that to get our slope. So 2 cubed is 8 times 4 is 32 minus 2 times 10 is 20. And then down here, that would be 4 times 6 is 24, also minus 20. So that's 12 over 4, which is 3. And then setting up our equation, it's going to be y plus 4 equals 3, parentheses, x plus 24. On the test, they do not leave it like that. They're going to go ahead and put it into y equals mx plus b form. So we're going to distribute our 3. This will be 3x plus 72. And then subtract over the 4. So it'll be 3x plus 68. All right, write but do not evaluate expression for the length of the path. So we're just going to have to set up our integral. So from 2 to 7, great big square root, dt at the end, leave it blank. I hope I left enough room for myself. And then what goes in there are the derivatives. So this would just be 8t. And this would just be 3. Now they are going to clean that up a little bit. So we're going to have to simplify down. So this would be 64t squared and then plus 9. All right, vector valued function is given by this. We want to find our derivative. These are both going to be a chain rule. So just heads up, this is going to be, really long here. We're going to bring the 5 down. It's going to drop to a 4. The guts of it, what's inside, is going to stay the same. So t cubed minus 4t squared. And we're going to chain on. There won't be a dot when they write it, but I like to put a little chain rule dot. We're going to chain on the derivative of what's inside, which will be 3t squared minus 8t. Comma, and we're going to do the exact same thing with this one. So the 2 is going to come down. Insides stay the same. It's going to drop to a 1, but you're not going to see a 1, in your answer choices. And then we're going to chain on the derivative of what's inside, which would be 4t cubed plus 3. I don't think that's a hard problem. It is a lot to look through. So whenever you're looking through your answer choices and they all look, sort of like that, it is a lot to sift through, but it's not necessarily like what I would consider a really difficult problem. All right, we've got a vector valued function defined by that. We want the derivative at pi over 6. This is going to involve some unit circle. We're going to find our derivative, and then we're going to plug in pi over 6. So derivative of cosine is negative sine, so it'll be negative 3 sine t. Derivative of sine is cosine, so this is going to just stay negative 2, so negative 2 cosine t. Off to the side, I'm going to draw a picture. Pi over 6 is in the first quadrant. Across from that is a half. That means the other side is square root of 3 over 2. If this was pi over 3, these would be reversed. So let's see. Sine is the y part of that. That's the 1/2 times negative 3. So negative 3 halves. And then cosine is the x part of that, square root of 3 over 2. The 2's are going to cancel. So just negative square root of 3. All right, this is our position vector. We want the velocity vector at time 5. All right, so we're going to find our velocity vector, and then we're going to plug in 5. So let's see, derivative of ln, it's going to be 1 over whatever that stuff is, t cubed minus t, and then you chain on the derivative of that stuff, but I'm going to just put it in the numerator so I don't have to put a little dot here. It'll be 3t squared minus 1. And then derivative of this would just be 2t. And then plugging in 5, it'll be 25 times 3 is 75, minus 1 is 74. And then down here, 5 cubed is 125, minus 5 would be 120. And then this part would just be 10. I guess this is going to reduce, but on the test, I don't remember the numbers coming out that big, so I'm not going to worry about it here. It's harder for me. Like the study guide is always harder than the test because I try to make problems modeled on what they have, but it's hard to force them to turn out a certain way. So you're not going to have numbers that large. All right, position is given by these parametric equations. At rest, that means your derivative would equal 0. So we want dy dx to equal 0. So we would have derivative of y over derivative of x equals 0, but really we just need the numerator to equal 0. So I don't even need this at all. We're going to find this derivative and set it equal to 0. So really it's going to be more algebra than anything else. So this derivative is going to be 9t squared plus 18t minus 72. I'm going to divide them all by 9. Where'd the 9 go? If you divide everything by 9 and it equals 0, you don't really have to write it because 0 divided by 9 is still just 0. So I just usually don't even write it and keep things simple here. So this is going to factor t times t. 8 would be 2 times 4 to get a positive 2 in the middle, 4 minus 2. So we get t equals 2 and t equals negative 4. Now this is actually a problem about motion. We have a part, we don't know what our particle is. Again, a particle could be a car or a train or a hot air balloon or an elephant, but there is something that's moving and we're talking about it being at rest. So we're not going to do negative times. We only want positive times here. All right, instantaneous rate of change, that means derivative, is given by this. They put r, that's for rate, but if you want to change it to a v, you can. This is velocity. We're given an initial condition. What is the position at -2? So we're going to take where we started. I'm going to actually just do the x part of this here. We're going to start with our 7 plus, and then we're going to add our displacement. Now, it might not start at 0. In this case, it starts at 1, and we want to go to -2. And since I'm using my x dimension here, we're going to use this first part. So 2 plus 10t minus 6t squared dt. And the good thing about this is I'm not even going to have to do the y one because whenever you do this, it's multiple choice. And if you just do x, you'll be able to pick your answer choice. All right, so the 7 is going to just kind of hang out there until we're finished here. We're going to do our antiderivative. So 2t plus 5t squared minus 2t cubed, such that, and then we're going to do upper minus lower. So plugging in -2, that's going to be -4 plus 20. Would that be plus 16? -2 cubed is -8. Negatives are going to cancel. All right, and then plugging in 1, which is going to be 2 plus 5 minus 2. I'm going to have to come up here because I ran out of room. 7 plus, what is that going to be? 32 minus 5. And so I'm getting negative. I feel like something is the matter there. No, not negative. Positive, sorry, 34. Yeah, 7 minus 5 is 2, plus 32 is 34. All right, so your answer is going to be, 34 comma something, but you don't really even need to do that part because it's going to be multiple choice. And you can if you want, but, exam is timed, all right? Just to show you how the setup would go, it's going to be the exact same thing, but you're using all the y dimensions. So you would start with your -1, and your integral would still go from 1, which is where your initial condition is, to -2, which is where you want to go. And you're going to use the y part of your velocity. So 8t cubed plus 5t dt. And whatever you get out of this is going to give you that second part of your answer. All right, position is given by all of this. Find the acceleration vector at time 1. So we have position. We're going to find velocity first, then we're going to find acceleration, and then we're going to plug in 1. So a few steps to this here. I like to set them up blank though. All right, so velocity, we're going to do derivative would be 4t cubed. And then for this one, I'm going to do a little bit of a margin problem here. This is 2t minus 1 to the power -1. So when you do that derivative, the -1 is going to come down. All of the guts are going to stay the same, and it's going to drop to a -2. But wait, there's more because you have to chain rule on the derivative of what's inside. So I'm going to chain on a 2. I'm just going to change this one to a 2 instead of putting .2 at the end. All right, so there's our velocity. Now we're going to do acceleration. 12t squared. This is going to come down and be +4. It's going to drop to a -3. Insides stay the same. And then you have to chain on the 2 again. So this is going to become an 8. And then lastly, we're going to plug in 1. So the first part would just come out to be 12. And then here, so again, margin problem. This is really 8 over all of that stuff to the third. So if I plug 1 into that, well, conveniently, 2 minus 1 is 1, and 1 cubed is just 1. So the whole thing actually just came out to 8. So kind of dodged a bullet there. All right, position is given by these two parametric equations. What is the speed of the particle at time 2? So speed is going to be this whole thing. And then we're going to plug in 2. You just don't put the integral out front. But we do have to do the derivative. So derivative of ln of t is 1 over t, only this one has an 8. So 8 over t. And then this one is really similar to what we just did up here. I'm just going to do a margin problem. It's 16 t plus 2 to the negative 1. So if I bring that negative 1 down, and then it drops to a negative 2. Now, conveniently for this one, there is a chain rule. There's always a chain rule. But the derivative of t plus 2 is just 1. So I'm not going to write like times 1. Nothing's going to change there. So negative 16 over t plus 2 squared. And then we're going to plug in 2 to get our answer. So 8 divided by 2 is 4. Squared is 16. 2 plus 2 is 4. Squared is 16. That'll actually just end up being negative 1. Squared is positive 1. And so square root of 17 is our answer. All right, so we have our vector valued function. In what direction is the particle moving at the point 21, 4? First thing we need to do is find what t is. They don't give us t for this one. So I'm going to sort of decide which one of these looks easier to deal with. Let me see, probably this first one. If you set this equal to 21, 21 minus 5 gives you 16. I need to think what number to the fourth would give me 16, and that would be 2. So we want when t equals 2, and we want to know what direction. So I need velocity here. Velocity is directional. Velocity is what gives you direction. So derivative would be 4t cubed, and then this would be 6 minus 3t squared. We're going to plug in 2. And so this would be 8 times 4 is 32. What would this be? 6 minus 12 is negative 6. So the x dimension tells you left and right. Since this is positive, that means moving to the right. The y dimension tells you up or down. And since this is negative, that means down. So if your x dimension was negative, you would be going left. If your y dimension was positive, you would be going up. So again, x is left, right, y is up, down. All right, this is your free response question. I will go ahead and tell you 3 parts of this are fairly straightforward, and then there is one part that is you're going to have to buckle up. So I'm just giving you a heads up on that. All right, find the slope of the, let me read what they gave us first. For 0 to 15, particle has velocity vector given by this. This is our velocity. And then we have an initial condition at time 0, which is nice, is 0, 4. So find the slope of the tangent line. So that's a derivative, which they gave us velocity. So we already have the derivative. We don't even need to find a derivative at time 3. Basically, you're just going to plug in 3 and just put y, your derivative of y over your derivative of x. And you don't have to evaluate this unit circle stuff for free response. You are allowed to just leave it alone. So it's going to be 3 sine of 3 pi over 6 over, and then this one is literally just 2. That's the answer. That's it. No one should get that wrong. That one is very, very straightforward. All right, speed at time 6. Also very straightforward, but you do have to remember the formula, right? So setting this up blank, and you want the derivatives, but again, this already is a derivative, so don't do anything to it. If you take a derivative of this derivative, then you'd have acceleration, not what we want. So we're going to take 2, put that there, and we're going to take this and put it here, but we want to plug in 6. So it's going to be 6, and I didn't leave enough space. Sine of 6 pi over 6, which would just be pi, but you don't have to simplify this. And I recommend you don't. Just leave it alone, right? Set it up blank, though, so that you don't forget the squares. And that is literally it. Write but do not evaluate, an expression that gives average speed. So we just did speed. To make it average speed, you need to put that 1 over whatever and then your integral. It's an average value. It's just our value is for speed. So it's an average value of speed in the first 15 seconds. So we're going to have 1 over 15 minus 0, 0 to 15, and then it's literally what you just did. But you don't want to plug in any number. Like this was at times 6. We don't want to do that here. So we're just going to leave it t sine of pi t over 6. And then again, counting my parentheses there. Don't forget the squared. That's why I like to set it up blank. You see how I was like, how many parentheses do I need here? If you set it up blank first, then you don't run into that issue. All right, so this next one is a lot. I do like it though because it pulls in a lot of different topics that we've covered. So it's a nice review of various things that we've done. So I'll kind of recap it when we get to the end. So it says find the maximum value of y of t on interval 0 to 15. Now, they don't throw the word absolute in there. I really wish that they did because I think that would be a better clue as to what you're supposed to do. But it is going to be a candidate's test. So your candidates are your endpoints and your critical points. Critical points are a derivative equals 0. Remember, this already is a derivative, and we're just using y. So I'm just going to use this part and set it equal to 0. So first thing we're going to do is take this t sine of pi t over 6 and set it equal to 0. You will get 1 point out of this if you even do that. If you even think to set the derivative equal to 0, you'll get a point. Now, if you set t equal to 0, you're going to just get 0, which is already one of our candidates. So I'm going to basically ignore this part. And this also pulls in some unit circle. We're going to have to think about where on our unit circle sine is 0. And we're going to set this pi over 6t. I'm going to write it as pi over 6t equal to those values. So just off to the side, let me draw a little unit circle. Sine is the y coordinate of the point. So that would be here. And right here, that ends up being 0. Now, we already did 0 pi. We already have 0. This would be 1 pi. And then if you solve for t, you're going to just get 6. All right. Continuing around, we have 0 pi. We have 1 pi. We're going to keep going. Also, pi over 6t could equal 2 pi. If you solve that, you're going to get 12. Keep on going because you can go around and around and around the unit circle. How do we know when to stop? Well, let's see. If we do 3 pi, we're going to get 18. I do not want that one, and we can stop. And the way that I know to stop is my last candidate is 15. That's the end of my interval. So I'm going to go ahead and set up my table. And my candidates are 0, 6, 12, and 15. I don't feel like that was honestly that bad so far. Okay, here's where we do run into an issue. We have to get an equation for y of t, which we don't have. They didn't give us position. They didn't give us x and y. They gave us the velocity. They gave us the derivatives of those. But they did give us an initial condition. So our initial condition is 4. So I'm going to come down here and start with that. And we want to go from 0 to t of that velocity. Now, because I'm putting t here, I'm going to use x instead. Technically, it should be a different letter. And then we're going to do an antiderivative. Well, you kind of run into a roadblock. How do you do an antiderivative of this? Think about some of the other tools we have in our toolbox. A regular u substitution is not going to do it. This is integration by parts. So u is going to equal x. Du would then just be dx. dv is the rest of this. v. Now, when you do your antiderivative of sine is going to be negative cosine, and you need your adjustment number. Now, pretend there was just a 3 in there. You would use a 1/3. If there was a 5 in there, you would use a 1/5. You always do the reciprocal. So the reciprocal of pi over 6 is 6 over pi. It looks like a lot, but all we did is take that number and flip it over. And just don't forget the negative. All right. So here we go. It is going to be u times v. So it's going to be negative x, or, well, I guess you can write that in sort of whatever order you want. I'm going to write negative, I guess, 6 over pi x. We'll treat that like the coefficient. Cosine of pi over 6x minus, that needs to go from 0 to t, minus integral 0 to t of multiplying these two together. Negatives are going to cancel because we're subtracting, but then there's another negative here, so that's kind of nice. And it'll be 6 over pi cosine pi over 6x dx. All right, here we go. Upper minus lower. So if I plug t into all of this, it's just going to basically be repeating this except with a t in it. Conveniently, if you plug in 0 for x, the whole thing is 0. I'm not going to write minus 0. We did do upper minus lower, but 0 is going to just give you 0 because of this x there, which is kind of nice. All right, antiderivative of this. Antiderivative of cosine is sine, but again, we're going to need this adjustment in there. So I'm going to have to multiply by 6 over pi again. So it's going to be 36 over pi squared sine pi over 6x such that 0 to t. Now I'm going to erase and just fix this, first of all, because I'm out of room, and secondly, I don't feel like writing it all over again. When you do upper, you're going to just plug in t for x. So I'm just going to erase this and put it t. And once again, if you plug in 0, you're going to just get 0. Sine of 0 is 0. So I'm not going to write minus 0. So we did do upper minus lower, just the lower ones ended up being 0. So this is our equation for y of t. We did it. Cool. All right, now we're going to take all these numbers, plug them in, see which one is the biggest. We want the absolute maximum for this. If you forgot what we were doing, this is what we're trying to find here. If you plug in 0, you're going to just get 4. That was the initial condition, was 4. Plugging in 6. So let's see what we get. All right, 4 minus, if I plug in 6 here, 6 is cancel, you just get pi. Cosine of pi, here's where pi is. Cosine is the x part of the point, which would be negative 1. So this whole part just goes to negative 1. Negatives are going to cancel, so this will be plus. And then 6 times 6 is 36, so 36 over pi. And then this part, if you plug in 6 here, the 6's cancel, you get pi. Sine of pi is just 0, so this will be plus 0. I think that happens a lot for these. You can get a lot of zeros, which is a nice thing about the unit circle. You get a lot of 1s and 0s. All right, plugging in 12. If we plug in 12, we're going to get 2 pi, which is right here. Cosine is 1. So essentially, you can ignore this part because it's just 1. And then we're going to plug in 12. So 12 times 6, what is that, 72? So this will be 4 minus 72 over pi. And again, if you plug in 12 here, you get 2 pi. Sine is going to be 0. Sine is the y value. Last one. All right, if you plug in 15 here, 15 pi over 6. 15 6 is going to reduce to, what is that, 5 pi over 2. That is going to be up here at the top. If you count around your unit circle, you have 1 half, 2 halves, 3 halves, 4 halves. 5 halves is going to be up here at the top, 0, 1, same place as pi over 2. Cosine for that is going to be 0. So this whole part is gone. It's 4 minus nothing. But we are going to get a value here. Sine there is 1. And then 1 times 36 over pi squared. So plus 36 over pi squared. So we figured them all out. Now, which one is the biggest? This one's 4. This one's 4 plus something. So this one's bigger than 4, so it can't be that. If we subtract, it's not going to be that. So one of these two is the biggest. Well, which one's larger, 36 divided by pi or 36 divided by pi squared? This one's going to be the bigger one, because if you divide by pi squared, you're dividing by more, and you're making this part that you're adding on smaller. So this is going to be our larger one. So here's our answer. Absolute maximum is 4 plus 36 over pi at t equals 6. It's worth a boatload of points. But if you even do this, you'll get 1. I believe it's the candidates are worth the second point. Your justification, which is the rest of your chart, is worth 1. It's a point for doing your integration by parts, and then a point for saying the answer. I think it's 5 is what that's all worth. But again, I like that because you have to know unit circle, you have to remember candidates tests, and you have to remember integration by parts. So it pulls in a lot of different things that we did. So it's a nice review problem that pulls everything in at once here. All right, here are our calculator problems. Position of a particle is modeled by these. We want the second derivative at 1. All right, so first let's get the first derivative, and then we are going to go to the calculator, but let's at least get our first derivative. It's not going to be, super difficult. Derivative of y, that's going to be negative 4e to the 4t. The 2 is a constant, so that's gone. Chain rule on another 4. Over, this 1 is going to be gone, so ignore that. Derivative of cosine is negative sine. So the negatives are going to cancel. We'll have positive 2 sine of 3t. And then I have to chain on a 3. So 2 times 3 gives us 6. So there's our derivative. Now I'm going to go to the calculator. And I'm sure there's a bunch of different ways you can choose how you want to type this in. Here's what I'm going to do. I'm going to write this derivative that we just found as a function. And I'm obviously putting x's instead of t's here. So that I can come down here and do the derivative of it. Oh, wait, what did we want to plug in? There was a number, wasn't there? 1. We want to plug in 1. Now, here's the thing, and I guarantee that's one of the wrong answers. You have to do that derivative of your derivative, but then you have to divide by dx dt again. That's what makes it like feet per second per second. So we're going to divide by this part again. I just need to plug in 1, which 3 times 1 would just be 3. So this is the answer that we want. So negative 7,629 points. Now, I would write 435 if it was a free response question. I would truncate 435. On the AP exam, when it's multiple choice, they do round. So it'll be rounded up. But no 2 answers are going to be close enough where that would even be an issue. Like you'll be able to pick the right one. All right, instantaneous rate of change. That means derivative of a vector valued function is given by this. Here's your initial condition. It's not at 0, it's at 5. Find f of 3. Once again, you would have to do an x and a y, technically. We're going to just do x because you'll be able to pick your answer choice just based on x. So we're going to take our initial condition plus our displacement, which is going to go from 5 to 3. And we want our derivative for the x part. So square root t cubed minus 4 dt. And I'm going to go to the calculator and type that in. And once again, that's going to give me this x part. I'm not going to do the y part. You'll be able to pick the answer based on it. But you would do the exact same thing. It would be 2 pi would go here plus integral 5 to 3, and then you would just use this cosine t squared inside of your integral. So I guess what I would recommend, just do the x part of it, pick your answer choice, and then later, like if you finish early and you have extra time, you could go back and do the y component as well, just to double check your answer. But I wouldn't bother doing it right away because, again, it's timed. All right, so negative 13.862. All right, 17. A particle has a velocity vector. So this is our derivative given by this. Another initial condition. This one actually is at t equals 0. Oh, this is interesting. How far is the particle from the origin at time 1? We are going to have to actually do both dimensions this time because we want our distance from the origin, which is interesting. So let's do x first. It's going to be 2 plus integral from 0 to, where did we want to end up? 1. And then I want to use the x part of that. Same exact setup for y. It's going to be 1/4 plus integral 0 to 1. And I'm going to use this 4 to the negative t dt. All right. This one's actually just going to be 7. It's going to be 2 plus 5. If you want to type that in, you totally can. Come over here. I do not know what the other one would be off the top of my head. So. Roll 0 to 1. All right, 0.791. Now here's what this would look like. Our x dimension was 7. Our y was 0.791. This is the distance that we want. I'm going to call it c because we're going to kind of do a Pythagorean theorem thing here. But we want our distance from the origin. So kind of like a component vector. So it's going to be 7 squared plus this 0.791 squared equals c squared. To get rid of this squared, you're going to square root. That's why that formula looks like that. It comes from the Pythagorean theorem. It's all triangles and stuff. All right, so 7 squared is 49 plus, and then I want to copy paste that number squared. And so that's our answer, 7.04. Now I would write 0.044 if it was free response, but 0.045 is what it's going to look like on the AP exam. They always round on the multiple choice. All right, so last one. An ellipse, which is like an oval, is defined by these parametric equations from 0 to 2 pi. Perimeter of the ellipse, that's the distance around the outside. So it's the arc length. So we want to go from 0 to 2 pi, big square root, set it up blank. And we want to put our derivatives in here. So derivative for this one, the 1 is constant, that's going to be gone. Derivative of cosine is negative sine. Negatives cancel. So it'll be 3 sine of t. Even if you messed up the negative, though, when you square, it's going to turn positive. So it's kind of forgiving. And then derivative of sine is cosine. So 5 cosine t. And then we're just going to put that in the calculator. All right, 13 point. Did I mess something up? Something doesn't look right there. Oh, forgot the 5. I was going to say, I was expecting a bigger number. There we go. 25.527.